Hello, Professor. This is Jordan. And for my simple structure, I decided to just go with a ceiling fan. Even though it's quite common, I find it quite interesting as it does need to be balanced in order for it to be, operating to its full potential. So I measured all of the components using an 8 by 11 inch piece of white paper. So the diameter of the base was a foot. Each fin is about 1.8 feet, and I calculated to weigh about maybe 2 or 3 pounds, and the whole structure maybe at most 25 pounds. So why it's important to draw a free body diagram for something like this is because it needs to be in the correct spot on a ceiling, especially if it needs to be airflow to a certain area of the room. And so I have the free body diagram here. Right here, I included that it has a lot of forces. So there's forces on the fins, on the entire object, on the entire fan, and also a normal force from the base of it to the ceiling. So downwards, you see that there's a force of the entire mass of it times gravity, and there's the force of the fins. Since the longer it is or the heavier it is, there'll be more force thrusted upon it, and it'll cause either the fins to droop less or more depending on how the weight is distributed. Also, it's just important to know that with ceiling fans, they need to be maintained and pretty much operational to its best ability, as well as there is tension as well across the fin. Same with the weight. The longer it is, the more tension it'll be spread across each one. Also here, there is some tension as well because it sways. There needs to be a little bit of sway to it because these fans spin pretty quickly, so it needs to be able to self-stabilize to a degree. And some of the challenges I found with the object was perhaps maybe I didn't include all of the tension, and I could have used maybe better measuring equipment such as a measuring tape or something like that. But other than that, I found it quite interesting, as well as just how everything works.